Cool. Let me put this question up on the board. So I'm doing Thermo 2017. I hope you guys have done that one. If you're not doing the Thermo exam, you can just keep working on your organic. I just want to kind of see what you guys want me to go over, because I'm mindful we only have about 15 minutes left in class, and I don't want to take too much of your time up. Cool. First question, were you guys okay with that? When you looked at it, it was just the formation of the hydrochloric acid and the equation for that. I'll just pop this one on the board, and if you guys feel like you need me to walk you through it more, I can. So, with that, remember you do need to know what those little letters mean on the bottom. So F is formation. Now I gotta remember the other one for combustion is C. And that all means different things. And then you should also know the other ones, which are fusion and vaporization and sublimation. Those are specifically for state changes. So just kind of be mindful of that. So this one here is talking about the energy released or absorbed, because we don't know, we haven't been given the delta H of 1 mole of hydrochloric acid when it's formed from the constituents of its element under standard conditions. So that's just your generic definition of what formation equations are. So do kind of keep that in mind. Whereas combustion equations, you're talking about the energy released or absorbed when 1 mole of blank substance is burnt in unlimited oxygen under standard conditions. So the key thing to remember about this equation then is that you need to set the product to 1 mole. So 1 mole of the hydrochloric acid. Then when you fill in the reactants, you need to do everything in reference to that. So it's very strange because it's different from what you guys are used to when it comes to balancing equations, but you are going to be using fractions to communicate this across. So do watch for that. If you have written H2Cl2 and then did an equal sign and do 2HCl, that's not the correct equation for formation. That's just the equation. Does that make sense to everybody?
What's the little number in brackets? What are those? You could just read the whole gas. Is that gas?
Yes. I can zoom up. Those are gas.
What gas?
Yes.
How do we know that it will be gas?
Let's see. Does it say in here? It doesn't. For me, thinking about it, hydrogen and chlorine are both gas at room temperature. I'm thinking about standard conditions. With the hydrochloric acid, you wouldn't necessarily know if it was a gas or a liquid, so I can see where you guys get tripped up on that. I would assume gas because I would think that it's a very exothermic reaction and it's probably going to evaporate any liquid. I don't think they're going to be... Oh, it says correct equations with states. Oh, wow. So they are really nitpicky. Yeah, I'm not really sure how you guys would be able to know that it's a gas instead of a liquid. I would just probably assume, under standard conditions of room temperature, if I did this reaction, it would probably form as a vapor. It wouldn't form as like droplets on a test tube. So, unfortunately, I don't have a good way to help you guys with that. All right, shall I move on? Yeah. You guys okay? All right, the next question was your calculation question. So what I might do is actually go through the document camera with that to make sure you guys are, oh, that's what I wanted, to make sure you guys are feeling, or you know how to process that question. Let me just move this out of the way so that way I can have that in front of me on my computer so I can check my math. Alrighty, cool. I want to take our time kind of going through and unpacking this question because the thing that's going to challenge a lot of people with this is going to be the decoding of it and pulling the information correctly. So they've given me 45 milliliters of 1.5 mole per liter of sodium hydroxide. So that's my first kind of thing that I'm looking for. So we're just going to do that as our first thing. Second thing is that it's added to 90 milliliters of 1.5 moles of the hydrochloric acid solution. So that's my second thing that is being used. So from that information, I need to then think about what type of calculation I have here. In this case, I have a neutralization reaction. I'm mixing 2 solutions. So with that information there, it'll help you kind of organize what to expect with what numbers to use. Does that make sense to everybody? Yeah. Okay. So I'm just going to write that this, when I look at it, is a neutralization. If you guys remember, the other two that we did were the dissolving question, where you're taking some solid and you're mixing it into the solution. And then the last one that you had was the combustion, and you're heating water from like a flame that is burning gas. Does that ring a bell to you guys? So those are the three different kind of categories you're going to get with this style. All right, so they want you to calculate the enthalpy for this reaction, assuming all the sodium hydroxide solution has been reacted. So this is to give you a hint, because you remember how I said we have to look at the equation and think, what is the limiting factor when we're doing these two solution mixes? Does that make sense to you guys? So what they're trying to do here is give you the hint of which one's your limiting factor. In most cases, they will give you two things that are exactly the same, so both will run out at the same time, so it doesn't matter which one you use. In this case, it does matter because you've used different volumes. I see that I've used the same concentration for both of them, but I have used twice as much hydrochloric acid as the sodium hydroxide. So what's going to happen is the sodium hydroxide will run out first, and then the reaction will stop, and I will have excess acid left over. So when I do some of the later calculations, I want to use the sodium hydroxide concentration and volume, and you'll see what I mean when I do that step. Miriam's looking at me kind of confused, so let me answer it, and then I'll show you what I mean. All right, cool. So I'm going to put this in green, which is my excellence. The reason why is because I want to show you guys the full answer, then point out where the merit and the achieved points were. So first thing I need to do is use my Q equation. So Q is equal to your mass times your heat capacity of water times the temperature change. And I forgot to underline the temperature change in there too. So it went from 20 to 24 degrees. That is my delta T, which is useful. All right, are we okay with that so far? Okay. So let's start plugging in information to figure out my Q value. And this is, again, like what I was saying, we need to be careful of what the numbers we're pulling. So Q is equal to my mass. Now, in this case, we're talking about the mass of the water. And so that's going to be the combined solutions together because the whole temperature of that solution is changing. So I need to put these two numbers together. And by putting these two numbers together, I would have 135 grams. 1 milliliter of water equals 1 gram of water. So you don't have to do any conversions. We're just adding these two numbers together. Then what I need to do is multiply it by the heat capacity of water, which they've given me, which is 4.18 joules per gram per degree Celsius. I find it really useful to write down the units so that way I can double check that I've set my calculation up correctly. And then my temperature change is 4 degrees Celsius. It's going from 20 to 24. Cool? All right. So let's go through and do my math and check. The Celsius cancels out, the grams cancel out. I'm left over with joules, which is what I want for my Q value. And so my Q value is, and I'm just going to copy the number over, 2275.2 joules. If I want, I can convert that into kilojoules and just divide by 1,000. It'd be 2.2752 kilojoules. Now, I am not rounding at this point. We want to round in any of our final answers. So keep it nice and long. Are you okay with how I got that first bit? Yeah. All right, cool. The next thing I then need to think about is the neutralization equation between the sodium hydroxide and the hydrochloric acid. In most cases, they will give you the equation. I'm very surprised they haven't. But the thing is, this is just a 1-to-1 ratio. So we don't have to worry about that as being a limiting factor either. Are you okay with that so far? So usually we give you the equation, but whatever they usually tend to give you is a 1-to-1 ratio. So they try to keep it as simple as possible. But what we need to ask ourselves here is, what is the limiting factor? What is going to run out first and then stop the equation or stop the reaction? Ellen?
I got 2257.
2257.
Yeah, I got that as well.
Oh, maybe there's an error on that. Let me plug it in too. All right, 135 times 4.18 times 4. Oh, you're right. There is a typo on my answer key. I will fix that on there. You okay with that?
Yes.
All right, good catch. You can see why when I look at these exams, I'm like, ugh, sometimes we pay for these things and they're just not always great. All right, so are we okay with what I've been talking about with the limiting factor? Okay, so the next equation we need to think about is my enthalpy is equal to the negative Q value divided by the N. So what we now need to think about is what is N. So N is going to be the limiting reactant. So when I say limiting reactant, we're talking about the reactant that's going to run out first and thus stop the reaction. So again, usually in most cases, they're very nice and they give you stuff that regardless of which one you use, it's going to be the same answer. In this case, they haven't been nice because they've given you same concentration but different volumes. And so we need to figure out which one's going to run out first. They've given you a hint here, and they say all the sodium hydroxide has reacted. So that's, again, trying to point you into this direction, that this is your limiting factor. So what I need to do is figure out moles. So for you guys, remember, concentration is equal to moles divided by volume. To rearrange it, N equals the concentration times the volume. So I need to plug that in. So N equals, concentration is in 45 milliliters, so I need to convert that to liters. And I need to multiply it by the concentration, which is 1.5 moles per liter. I see that the liters cancel out, which is what I want, and I'm getting a mole value. And I get my mole value to be 0.0675 moles. Did you guys get that? Okay, cool. Just checking their math. All right, then what I do is I plug in all my numbers. So negative Q value. So I have negative 2.2572, that's a 7, kilojoules, and I'm dividing that by 0.0675 moles. Now I'm going to get an answer that's kilojoules per mole. My delta H value is negative 33.7 kilojoules per mole is what you should have. And now this is now in 3 significant figures. 33.4. Let me just double check them. All right. 2.2572 divided by 0.615. They have another mistake here. Yeah, you're right. It's 4. I see. It's because they carried over that mistake from swapping those two numbers around. Yes. Yeah. So the reason why the answer key is wrong is because they swapped that 7 and that 5 around. Yeah. So that's the correct answer. That got you up to the excellence point, but you needed the significant figures. You needed the units. The merit was calculating this number here. So you got this number with a minor calculation error. They're very vague on that. And then for the achieved was finding that Q value. So basically you were able to do this first step here. Are we good? All right, please hand in that question because I would love to have a look at it and use it as credit and evidence for your unexpected event grade. Anything else that you have finished during this period, please hand it in to me because I know you guys have been busy working away. But the more you hand in, the better, because then I have a larger sample size of evidence to kind of estimate your grade. Yeah, I'm happy to take stuff off of the mocks too. So no rush if you haven't had it done. All right, anything else? All right, please hand in this question that you just completed so I can give you credit for it. Hopefully you guys have written in red pen for any corrections. Give me back my little Ziploc bags of highlighters and things. And then any other work you completed this period or over last night, hand it in too. Thank you.